Okay, good morning, folks. So welcome back to the session on data mining and data warehousing. We are discussing the topics of classification, and in classification, we saw two methods, two important methods. Of course, the first method we saw in detail. The second method we saw basically how what it is and all. The third and fourth method also we are going to see the introduction part of it, or mostly the part that is required for you to understand in very basic terms what it is. Okay, and in detail of it, if you want to know, then as of now from the data mining perspective of your 6M VTU syllabus, it is not there. Maybe the extra point, if possible, I'll be including everything in your PPT and we'll be sending you as a notes, so you could always sort of use that for getting to know some extra points. Okay, but from a VTU point of view, whatever that is needed, that probably you would have seen it. Okay, so what are the things that we saw? We are talking about the classification aspect of it, and in classification we saw two methods, right? Once again, two methods. What were the two methods? The first one was with regard to decision tree induction. Okay, a very important aspect. A lot of things which you people sort of come across is with regard to decision tree. Okay, how do you deduce decision tree? What are the ways that it is going to come? Based on what the decision tree will be analyzed, all those things you learn. And then in the last class you came across what is known as the rule based, okay, classification. All these things comes under classification only, that you got to keep in mind. See, because there may be a question asking define classification, explain the different approaches to classification with examples. Okay, they may not go for such a huge generative statement or a general statement like that, but if they ask, you should be able to know what are the things that are there in the syllabus aspect of it. Decision tree is the first one, then you have the rule based classification. Now I think today you are going to see the nearest neighbor. Okay, in general the k nearest neighbor, near, what is the spelling of nearest neighbor? Okay, our nearest neighbor, okay, classification is the next one, and the last one is with regard to Bayesian one. Okay, here also it's a very huge topic with regard to Bayesian classifier. We are only going to study the formulas of it. See, even in nearest neighbor we're only going to see, we'll go take one example and we'll see how it is calculated and all. But KNN, K nearest neighbor, is a huge or a very important algorithm which you people need to keep in mind, especially in terms of machine learning and data science. Okay, same with regard to Bayesian classifier. Very important algorithm for you to remember in terms of machine learning data science. But from a data mining perspective of our syllabus, whatever that is needed, that we'll do. Extra points will be there in the extra segment. Okay, in the PPT will have an extra segment there, it will be having there. Okay, make sure that if people are getting to know all these things. Okay, so these are the entire four things that you have come across under classification. Okay, this is under classification. See, look into the first aspect, module 1 and module 2. You basically talked about the what you call the introduction part of. Here it was basically with regard to data warehousing, lots of data warehousing, and here it was a combination of data warehousing, efficient data computation. There it starts from then, and you learned about the basic principles of data mining, module 2. Then from module 3, you basically went into the applications or the segments of data mining that are important. The first one you saw, association analysis, which was one of the tasks of your data mining. Okay, association analysis here. Module 4, you seeing with regard to classification. And in module 5, I think, which you are going to start from the next week aspect of it. Okay, because only these two are there. Once it's all done, you are going into learning what is clustering aspect of it. Okay, how do you cluster the data? How do you put data into different clusters or group data into different clusters? Here, how we are going to classify data into different segments. What are the approaches to it? Here, association analysis, you are going to see how if 2 or 3 data items, if they are related, what is the rule that you come across? How they are related, association analysis. Like this, you come across so many things. Okay, you read all these things, it's all over. Data mining, data warehousing, the entire chapter. As you can see, why the thing starts with data mining and then into data warehousing, even though it was started first, because majority of what you study is related to data mining. Okay, and of course the introduction part of your data warehousing. See, warehousing you do only to make sure that you have a very efficient data mining, algorithms being placed into it. Okay, so that's mining is important. To do mining, you have warehousing. That also you study. Along with that, then you go with the flow of studying data mining. It's not only these. There's a very important question in module 2 that we would have seen. What are the different tasks of data mining? Go back and check into that. You will see all these 1, 2, 3. Along with that, there are other things also. Okay, there are other things also which you are supposed to study, which you're not going to study from a syllabus aspect of it. Okay, yeah, fine. See, I think from the next week you will be having a different timetable. Okay, due to the fact that I think all your labs, everything is all complete. So you have a different timetable from the next week, which is from Monday. Okay, probably more classes with regard to theory. So class to the last aspect, the last module of clustering will be done there. Okay, a lot of things. We'll try to put in some extra things also with regard to clustering. Lot of again theory thing will be there. Little bit here and there the mathematical things that will come. We're going to put that also in module 5. Okay, since that being the last module, we'll try to take it as much time as possible till your last date to figure out the best things that are possible. Okay, everything that we can learn with regard to clustering, we'll try to do that. Okay, so let's look into the things of what is today with regard to nearest neighbor. Before we go into that, okay, think all your marks, your fifth sem marks, for example, are put in some sort of a graph like this. How do you think I'll put it? I'll always put it in form of a graph like this. This obviously being 0 and this being your 100 marks. Majority of your marks, if I put everything in form of a graph, will be around, and of course this would be your 50. Okay, what example again? I'll take an example of your, what is that? One second, I'll just make sure that no one else is coming. Okay, I've seen few instances of other people and all are joining it, so let's limit it to people, okay, who we want. Okay, fine. So please mute yourself. Okay, so see what is the data if I put. If I take an example like maybe a management entrepreneurship subject, majority of your marks basically come like this, somewhere close to here. Very few people here. I think only 2 people are here. Majority of you will be coming right here itself like this. Okay. Now, what do you call these people? These people are outliers. There's a very famous book called Outliers. I don't know how many of you seen it. The very aspect of outliers is you're talking about something who don't really belong to the herd, who don't really belong to the crowd. Okay, but if the data is being put in form of like this, and there is something like this again. Okay, and there is something like this again. What do you call this? You call it as clustering. Very simple aspect is you call it as clustering. You are grouping data, okay, based on what is known as the data points. Okay, see, this is one way of clustering. This is one cluster. So you can call this as any things. Okay, it can be marks, it can be COVID, amount of COVID active patients, amount of COVID active nations. You can call it anything like this. If the data is sort of grouped like this. But what if the data is basically grouped like this, where you have all the data is being put in through like this? Okay, and you need to figure out what are the nearest people who are coming through. There are, think that, my average marks is 60 marks in my ME. Who are the students who are almost close to 60? The people who are 59 who is close to 60. People who scored 61, they are close to 60. 58 is also close to 60. 62 is also close to 60. They are neighbors to me. Okay, they are neighbors to the value which I want. That I can easily say. Okay, I can very easily say that all these people are neighbors to me. Okay, what is the next thing I can say? If I have neighbors to that, can I calculate the distance for them? Yes, I can easily calculate the distance. How? Okay, calculate the distance between 60 and 59. That is nothing but equal to 1. Okay, calculate the distance between 60 and 61. That is also equal to 1. How? Because I'm not going to take what is known as what? The negative or a positive aspect of it. I'm only what you call knowing about the distance. See, we have what is known as Vidyanagar cross right here. Towards this side, who is my neighbor? maybe Unsmanalli. Towards this side, who's my neighbor? Say Chikjala. Okay, I can't say this as minus and this as plus, or this as minus and this as plus. What is my job? My job is to figure out my neighbors. Who is my neighbors? Towards this side, you have not Unsmanalli, maybe Betalsur, right? So towards this side, I have my Betalsur. Towards this side, I have my Chikjala. Okay, so these are my neighbors. You have this and these people who are my neighbors. Okay, so these things only I'm sort of getting to know. I'm not worried about whether it is a minus distance or a plus distance. In the same way, I have to get like this. So to do this, what I need what is most important part of whatever the value I get now at the end, I'm going to square it. Okay, I'm going to square it. So what is going to happen? I'm going to get only positive value to it. Even if it is minus 1 square is equal to 1. Okay, so what is the purpose of doing this? To make sure that I'm only knowing what is known as the neighbors and not worried about my distance aspect of it, positive, negative, and all. Okay, so let me sort of look into that. If that is going to happen, what is a way of doing it? You figure out what is known as Euclidean distance. There's a very famous aspect of Euclidean distance which will be used to figure out the distance between things. Okay, but why do you need all these things? Okay, why do you need all these things, and how do you figure out where you need to place it? You got some a fruit. Think there is a fruit like this. You don't know where to place, whether it is an orange, you don't know, whether it's an apple, you don't know. Okay, whether it's a mango, you still don't know. So what do? You take out these characteristics, right? You basically take out these characteristics, and what do? You compare these characteristics with the characteristics of orange, apple, and of course mango. You're going to compare the characteristics. Then what is the next thing? Whichever characteristics is almost near to it. Is it an orange, apple, mango? You're comparing, when you're comparing the characteristics of it, whichever characteristics comes close to it. Okay, that fruit will be placed in that category. Now, if you take apple, there are various types of apple. Clustered apple, that apple, this apple, so many apples are there. Orange, again, so many types of oranges. Mango, you must be knowing. Okay, mango, probably you must be knowing that they are close to around 40, 45 different types of recognized types of mangoes. Okay, in entire India. Unrecognized, there may be even more. Okay, so when I say recognized, you must be knowing, right, the different breeds of, or what do you call them, species of mangoes. You start from that Alfonso, very famous in Maharashtra. You come to that Banganpalli, very famous in Andhra Pradesh. Come to Karnataka, you have this very big one. I don't really remember the name, that one. Okay, like that, you have different species. Now, if you take something which you don't know and you want to place it in any one of it, okay, then you see up the characteristics, you compare with the characteristics of it. Based on that, you're going to place it in a place like that. Okay, that is what the purpose of what is known as the nearest neighbor would be. To make sure that I am placing my data in the nearest neighbor, or I am calculating who is my neighbor. Okay, who is my neighbor? If I get to know my neighbor, I can figure out what are my characteristics and his characteristics. Then I can make a general characteristics. Okay, so let me go into that. And where is it? Yeah. See this example, very simple example, very famous example. So what is the basic idea? The basic idea is very simple. If it walks like a duck, quacks like a duck, quack you must be knowing, okay, the ducks quack, quack, quack like that. Okay, then it's probably a duck. They're not saying it's a duck, it's probably a duck. Okay, so what are the training records? See the way it's been written. Okay, the training records you can see. See, there is a hen here, hen or cock, okay, whatever you call it. And there's a duck here. You have a duck along with a chick. You have a swan here. Okay, there's a difference between a swan and a duck and all. Okay, again, I'm not going too much into zoology, because last class it was too much into zoology. Okay, so there's a difference between a duck and a swan. Okay, ducks don't really fly that high, and there are ducks which don't even fly also, but swans do it. Okay, swans do fly very high. They even go very distance also. And you must be knowing with regard to the normal cock or a hen and all. They don't really fly. Even if they fly, they'll not be flying more than 20 feet. Okay, because the evolution has made them to be very much in a precise environment or a compromised environment. Okay, see if this, whatever the household chicken, if they can fly, will you be able to rear it? No, it's very difficult. Okay, so evolution has made them. See, initially they used to fly, but thousands of years of evolution has made them to be able to be with the humans itself. So even if they fly now, they don't really fly that high. Okay, that's called theory of evolution. Okay, one of the simplest example of theory of evolution, that years down the line, we adapt to the environment and we become one in the with regard to environment. Okay, we survive based on the environment which we live. Everyone we had tiles, but became, because we didn't require tiles, our tails got, what do you call, didn't come into picture later part. Okay, theory of evolution, do read it. There's very, very, very good novels with regard to theory of evolution. Do read about that. Okay, get to know about it. Science should always be the background. Okay, don't leave it. Because anything, okay, everything and anything in the world can be explained based on that aspects of science. Okay, when I say science, general science. Okay, see what's the next thing. Okay, see what is the training records. We have all these training records, and you can see the different training records. And then what you do, you compute the distance between each and everything. Okay, and we choose the k of the nearest records. What is this k? K is assumption. What is that k? K will be chosen in such a way that we are able to get the best results out of it. See, you can see very clearly it is walking like a duck. This one walks like a duck. Okay, there's a duck with a chick which doesn't really come with a distance. Swan again a very far distance. Again chick very near. Okay, you compute the distance among that, whichever is the nearest distance. Okay, nearest. That's why it's called. That's why it's named it as nearest. Whichever is nearest, you name it as that. Here in terms here we are talking about duck, so we are coming like this. Okay, very, very important to sort of understand these things. Okay, so let me go to the next part of it. What is the thing that you see? Again, we take what is the nearest neighbor classifiers. What is this? All these things, right? You see plus one, all those things are records, test records and all. See, what does it be required for with regard to nearest neighbors? You require three things. Number one, you need a set of labeled records. Okay, good. Then you need a distant metric. What is a distant metric? How do you calculate the distance between neighbors? I told you about the Euclidean distance, right? That is only going to come. Okay, how do you calculate the distance to compute distance between the records? So you need records, you know how to calculate the records. Okay, and then the value of k. What is a k? The number of nearest neighbors to retrieve. This k is assumption generally. Okay, generally assumption, but generally it will be more like whatever the value you have, test records you have, okay, average of that. What is the meaning of average? If you say 10 records, average of it is say divided by 2, so it is 5. Okay, or the half of it. That's the right word, half of it. Okay, so to classify an unknown record. So if there is an unknown record, how do you compute? You are going to compute the distance to other training records. So you take an unknown record. So this is an unknown record for me now. 1 second, I'll show the right list. Yeah, see, this is my unknown record now. What I'll do, I will calculate the distance from here to various places. That is what you can see very clearly here. First point, you are going to compute the distance to other training records. Next one, we are going to identify the k nearest neighbors. In that k nearest neighbors, okay, and then use the class labels of the nearest neighbors, or in very simple terms, we are going to use the characteristics of those neighbors to determine the characteristics of the unknown record. The example I told you with regard to the fruit, this example, right? The example of taking a fruit, taking its characteristics, comparing with the characteristics of the various fruits, you get to know, okay, this characteristics is matching maybe orange or apple or mango.
Or what if there is a case where it is not matching any one of it? Then you need to compare the characteristics with another fruit. Or if you think there is no more fruits, you have to name it this as a different fruit altogether. So you can't put a mango in an apple or an apple in an orange. They are different. Just like that, maybe this fruit is different. You have to put it in different way. Or whichever is the nearest one. Okay, there you are going to put it there. Maybe it's a melon. Okay, you must be knowing different types of melon, musk melon, watermelon, that melon, this melon, so many melons. Okay, melons are generally wines. Okay, I don't know how many of you seen the plants will be like this, and you have a melon that will be grown like this. Okay, so they basically they don't really grow on top like this. They go down. Okay, that's a family of melons. Watermelon, muskmelon, like that. Okay, and you have the family of mangoes which basically happen in mango trees. Okay, you must be knowing mango trees. Apple, again, very much in apple trees. People who are from the areas of JK, HP, Himachal Pradesh, UK, Uttarakhand, okay, even from the northeast. Okay, they will be knowing, or to some extent right from West Bengal, but what I want to say, West Bengal towards the regions of maybe Siliguri to some extent, maybe Darjeeling to some extent. These people will be knowing or would have seen an apple tree. Or even in Tamil Nadu, okay, or the hill stations, okay, to some extent, very, very few instances, they would have seen in Tamil Nadu. I'm talking about the hill station, okay, like Udakamandal, or what do you call it as Ooty, okay, or so to some extent even in Kodaikanal. Okay, some places like that you can see the apple tree. Otherwise, it's not possible to see apple tree in our SSE campus. Okay, or in Bangalore. Before they say, before we used to grow apples in Bangalore also, it seems, but now the weather is not that conducive. Okay, oranges, people who are from Maharashtra, especially in Nagpur regions, okay, they would have seen a lot of oranges. Okay, like that. Okay, see, you take a thing, and melons, everywhere it grows. Okay, everywhere it grows. The very famous melons is with regard to your watermelons, which are grown outskirts of Bangalore. You see a lot of people grow watermelons during the summers, right? So that's what we are going to talk about. We are going to figure out class labels, matlab the characteristics. Class label, we call it class labels because when you take a data, it's all about labels only, the attributes. Okay, of nearest neighbors to determine what is the class label of an unknown record. Okay, by taking what? The majority vote. So if there are records like 3, 5 is matching one, 3 is matching another one. So which one we'll take? We take a one which is majority, 5. Okay, because we live in a democratic country, so we always go with majority. Okay, that's the next thing. So let me look into the other the examples of nearest neighbors. Okay, the examples being this one nearest neighbor. So what is the meaning of that? You see that the cross mark or the X symbol there, that X symbol is one nearest neighbor. For X, who is the nearest guy? The one that you see right here. Okay, this is the nearest guy. Okay, this is the nearest person. If it is with regard to one nearest neighbor, if it is two nearest neighbors, you have this and along with the plus symbol that is coming in. Okay, plus symbol coming in because that is also nearest. Then if you go for three nearest, or in very simple terms, they are calculating what is the for one data point, 2 data point, 3 data point. If you go for 3 data point, see 1, 2, along with that, there's one more thing also that's coming in here. If you go for fourth, which one is nearest? Probably you are going to start from here. I think the nearest from here, of course, we can't say like this. We have to calculate the distance, but maybe for an assumption, we could name the ones that are coming right at the periphery of it, which will be probably either this or even this. Either one of it will be taken into consideration. Or if all are having same distance, then four means 4 nearest means you will be having all these things coming into picture. Okay, that's very important. So this is how the examples of nearest neighbors. Now what is the next thing that you can figure out? Okay, see, there's a problem here. In this problem, even I don't know whether it's the going to ask in exam and all, but we are going to put a problem. Okay, we are going to put the problem in your PPT. It will be there. Okay, because without that, there's no point. Okay, Just reading theory, there's no point. Okay, some will be doing one problem at least. Okay, let me go into the next part. Okay, next part is, see what is the algorithm that you see. This is the algorithm. Again, it's taken from the textbook. So people who see this, it's not looking good and all. It's right from the textbook and all. Okay, the key k nearest neighbor classification algorithm. Let k be the number of nearest neighbors. T is a set of training examples. So D is the database. Okay, for each test example, we are going to figure out a distance. Okay, we are going to figure out the distance. How do you figure out the distance? We are going to compute dx comma y, the distance between z for every example. Okay, we generally use Euclidean distance. Very simple of simplest measures to calculate distance, Euclidean distance. Okay, so this is the algorithm that you need to keep in mind. You will not understand this now. Okay, you will not understand, just like how we did with regard to, remember, the algorithm which you learned with regard to FP growth. Okay, or an APROE, where generally when you see an algorithm, you will not understand. But once you do one problem now, and then you see the algorithm, you'll get to know like what is the mathematical representation of it or not. Okay, like that only we are going to do. So we are going to take one examples and we are going to work through about it. Okay, now what is the next thing? The Voronoi diagram of it. Okay, which is nothing but a one nearest neighbor. Okay, what is Voronoi diagram? Going to see that later. Okay, now what's the next thing? The most important part, because this is very important. If you know this, we'll get to know the problem of it. Okay, see, I told you I was talking about calculating a distance many times. How do you calculate distance? You can calculate the distance between any 2 points with the Euclidean distance. How you do it? Like this. Okay, from P to Q the whole square. I told you why I'm taking the square also. Because I'm not really worried about whether it is plus or minus. We are talking about only distance here. See, from Vidyanagar, I'm not worried about whether distance of Betalsur plus 1 kilometer or minus 1 kilometer. No, I'm only talking about from Vidyanagar 1 kilometer. Okay, towards that side you go and you go what you get up also. Towards this side, towards the right hand side, you go 1 kilometer, you get one more place. I'm only talking about in terms of values, not in terms of the signs of it. So for that, you get what is known as a Euclidean distance. Okay, the next aspect of it. How do you take this? Okay, how do you generally go for this? Okay, how do you figure out what is the things to be done for this? We have an example for it, but before that, we can see this. Okay, we are going to determine the class of the nearest neighbors list. Okay, what do? You take the majority vote of class labels. So in what is the meaning of this? You take the value which is maximum. Okay, among the k nearest neighbors, you take the one which is having the maximum. Okay, weight the vote according to distance and all this we're going to see later. So what are you going to take? We're going to take one example. And you will get to know what is the very purpose of this Euclidean distance. Okay, so let me take one example and you can see this is how the Euclidean distance would be. We are going to take this example. Hope you can see the example. Okay, see there's again it's an example right from a very famous place. Okay, because at any time if you see, you should be able to sort of relate your PPT with the one which you see in the World Wide Web. Okay, that's very important. So you can see very clearly what are the things I have. I have customer, names of it, I have age, I have loan. Now what are the two places where, and next thing is default. And the default data is already given. This is test data. The test data is already given. Last one is not given. Check, the last one is not at all given. We need to figure out that. We need to figure out whether this guy, Andrew, whose age is 48, will be a defaulted guy, whether he'll be, having a default loan or he'll be paying back. We need to predict the Andrew default status by using the Euclidean distance. Okay, now what is the loan amount is also given. Age is also given. Now, very clearly you can understand, of course, common sense also says, how can you determine whether a person will be able to pay the loan or not? That can be determined, based on not by his name. It's not like, okay, John is a defaulter, Smith is a defaulter. So Anil, okay, he is not a defaulter. Pat is not a defaulter. Based on the name, you can't say that whether he will be paying back the loan or not. Okay, that's never possible, right? Based on names, no one can decide. That's not, see, if you do it based on the names or based on the color of the screen or based on the place of their origin, that's called racism. That's what racism is all about. You are determining everything, or you are differentiating a person based on his origin, based on how he looks, or based on how he talks, which is called racism. Okay, you will get to know more about this. Okay, if you are trying to go to any further studies, and there'll be a very big book. Okay, when you say further studies abroad, will be a very big book that will be given to you to determine what you need to speak, what you should not speak. In India, everything works. Sabhi chalta hai. Okay, whatever you say, whatever you call, nothing happens. Abroad you go, especially the Western countries, Europe, the Americas and all, you call any person by anything, that's racism, and you are going to very, very serious trouble doing that. Okay, so you can't determine whether a person will be paying back the loan or not based on his name. So that's not possible. So only two things that are possible is with regard to age and loan. So how do you do it? You calculate what is known as a Euclidean distance. How? Very simple. You take this 48. Okay, see this? You take this 48. Okay, you are going to do the Euclidean distance with regard to John. You calculate for each and every one, you are going to do it because you need to calculate who is my neighbor, right? Who is my neighbor? I need to figure out. So I take my age, I combine that with this age of John. I take my loan, I combine that with my loan of John. Then I get a value. I'll write it there. Then I do the same thing for Andrew with Smith. Then again do the same thing for Andrew with Alex. Like that, if I'm keep on doing like that, at some point, okay, at some point I'm going to get all the values of them. Then what is the next thing I do? What is the number of data we have? I think we have close to 11. 11 by 2, 5.5. So maybe 5. So I'm going to take k as 5. And whichever value is nearer to that k is equal to 5. And what is the characteristics? Whether they fall under default, n, which is nothing but no, or yes. Okay, that will be determining whether I will be able to say that person has a defaulter or not. How is that? Very simple. Euclidean distance again. Okay, what is the way of doing it? See, very simple way of doing it. 1 second, I'll move the screen. Yeah, see, what is the way of doing it? First value I need to figure out, right? So let me go here. The first value I need to figure out is with regard to age and then the loan. So I'm going to do Andrew 48, John 25, age. Okay, with regard to age, I'll do like this. 48 minus 25 whole square plus this is with regard to age. I'll take this out. Okay, then the loan amount. Now with regard to loan amount. What is the next thing? Next thing is, what is the loan amount? 142 and 40. Okay, so I'll do the same thing here. 142 minus 40. Okay, 40,000, I guess. What is the value you get? This is with regard to the last person. Who's the first person and the last person? John and Andrew. Okay, John and Andrew. If you figure out the values of, you're trying to figure out whether where do Andrew fall, whether he's a neighbor to John or someone else. So next one, who is it? Smith. Okay, you are going to compare that with again with Andrew. So what is the value that is going to be unchanged? The value that will be unchanged is the 48 is going to come again, and this 142 is going to come again. Next again, what is the next person? Who's the next person? Alex. So this Alex and again Andrew. So same 48 minus whatever the value of Smith plus same 142, whatever the value of your next person. Then you get a value like this for each and every person. Then you take a k. Okay, you figure out based on the k value, figure out among all these things, who is the person who is having a value which is almost same to here or equal to here. That person attribute you check whether is falling under a category of no or yes. that person attribute will be attached to our Andrew. That is the neighbor of these many people, and his attribute is he's going to pay the loan or is not going to pay the loan, like that, simple. Okay, very important problem. You're going to do a the lab program also based on this in the next sem probably. Okay, you're going to do not lab program, if not lab program, at least problem will be there. Okay, you are going to do it, very important thing. Okay, now if you take like this, that's what the next thing that will be, you can very clearly see, this is what I was talking about. If you figure out the Euclidean distance for each and every person, okay, the Euclidean distance you can see easily figure out. First step is, I told you, this is what I did. The ones which you see right here, that's what I did, right? Square root of x1 minus y1. What is x1? The one that you needed here is with regard to 48. You compare that with 25. Then 142, you compare that with 40. Okay, and then you get a distance 102,000. Then you do the same thing with regard to Smith. You get a distance 82. Same thing with regard to Alex, 62. Like this, you get a values like this. Okay, you're going to get the values like this. Now you don't know where do you think Andrew will be falling to. Okay, based on what the Andrew will be falling to. For that you need to have a value of k. Okay, for that you need to value of k. Based on k, you will determine where do you think this guy will be falling to. Okay, how do you choose k? Where do you think? How do you think the k value will be able to determine this? Okay, how do you think k will be giving you the value of all these things? Okay, these things only we are going to learn in the next class. Okay, I think it's the 11:37. See, because we take that, it will take to around 10-15 minutes, but that's not right because you have another class. Okay, so see, what is the thing here? If you know the value of k properly, generally majority of the times it's assumption. How it is assumed or how is come to an assumption like that? It is done based on a number of your training sets or data sets. Here we have 11. Okay, except Andrew, you have 11. So around 5 we take. Okay, whichever falls under closer to your value of 5. That will be considered as your what? Will be considered as the attribute who is nearer to your Andrew. Okay, and then you will be working upon that. Okay, then you will be working upon based on all those things. Okay, if you go to the next part of it, how do you choose this? You're going to choosing the value of k. How are you going to choose? If the k value is too small, if you choose a small value is too small, almost everyone will be neighbors only. Okay, it is sensitive to neighbor points. What is a sensitive to noise points? Okay, it basically means everyone will be neighbors only. See, it's like this. Okay, if you keep your standards too low, everyone is good only. If you keep your standards too high, very few people will be your friends. Okay, very few people will be your friends. So that's the thing that you got to keep in mind. If the k is too large, neighborhood may include points from other classes also. If you keep the values to be too big. See, my point is here. I take the point to be too large. So everyone who is not at all related also will be coming to me. If it is too small, I will not be able to include anyone also. Okay, so this is the conclusion that you got to keep in mind. Which one you need to choose? The simplest part is go for an average because you will be able to choose almost everyone. Okay, go for an average. So only those people who are outliers will be taken out. Choosing the value of k becomes very important here. Okay, so all these things you are going to learn, the scaling issues, everything on a very important topic. Okay, the next tomorrow's class with regard to nearest neighbors. Okay, we will do one problem also along with the problem which you saw today. We'll take one more problem. We'll be doing it. Okay, everything will be there in the PPT because without problems, it becomes highly incomplete. Especially when these topics are something which you're going to write a program. So in the next coming up.